Very important because based on this chapter, the concepts of other topics are related. So that is why this topic has been taken as the first topic. So the name of the chapter is Units and Measurement. So first of all, we'll try to know what is the meaning of unit. Unit means a standard quantity based on which the similar physical quantities can be compared or measured. Say, for example, if I say a line segment of 2 centimeter. So what is the unit to measure here? The unit is centimeter. So what we are doing, we are comparing it with 1 centimeter. So 2 centimeter means there are two 1 centimeter lengths included in this. And where do we get this centimeter? We get it in a scale. However, little later we will understand why we have taken centimeter and meter as the unit of length. So for that, a different concept is there. We will go deeper into that little later. Next topic is measurement. In the previous definition, you must have seen that I have used the word compared or measured. So measurement is nothing but comparison of magnitude. In simple words, value of any quantity with its standard unit. Let us take one example. As we have taken example 2 centimeter, here centimeter is unit and it is 2 times of 1 centimeter. So it is showing how many times it is more than the unit value, the magnitude. So my measurement is nothing but comparison of magnitude or value of any quantity with its standard unit. So there can be various physical quantities and each of the physical quantities will have different units. So there are certain fundamental physical quantities and there are a few derived physical quantities. We will see a few fundamental physical quantities. All the physical quantities can be derived from some basic physical quantities like length. How do we measure it? We measure it using the unit called as meter. Mass. We measure it using a standard unit called as kg, kilogram. Time. we measure it using second. Now there are certain system of units, because these units have developed over a period of time. So in earlier days, and even in a few countries, the length is measured in terms of foot, weight is measured in terms of pound, and time is measured in terms of second. So in this case, it is called as FPS system. After that, the method of measuring length with centimeter, mass with gram, and time with second became popular. This is called as CGS system. Then after that, MKS system came. MKS means meter, kg, and second. It's called as MKS system, where meter is as we have taken earlier, kg is as we have taken earlier, and second is as we have taken earlier. So it is also called as MKS system. But nowadays, the best method which is followed universally everywhere is SI unit. SI unit means Standard International Unit. SI unit is quite similar to MKS system, very close to MKS system, because this system of units have developed over a period of time. So MKS is quite closer to SI system. In SI system, we take distance as meter, small m, mass as kg, and time as second. Now, using these physical quantities, which are fundamental or basic, we can find out the units and the physical quantities which can be derived out of it. Like, if you try to find out area of any two-dimensional object, then say, for example, if you take a square, it will be length into length. So area is a derived physical quantity, length into length. If it is a rectangle, length into breadth. If you take volume of any cube, it will be length into breadth into height, which is equal to length into length into length. So volume will be equal to length into length into length, or L cube. So based on this, its unit will also change. So for one length, we'll take 1 centimeter. For another length, we'll take another centimeter. It will become centimeter square. It will also become centimeter square or meter square. It will become centimeter cube or meter cube. Depends upon what is the unit we are taking. So these type of physical quantities which are derived from fundamental physical quantities are called as derived physical quantities. So derived physical quantities from length could be area and volume. Similarly, derived physical quantities of mass and time could also be there. So let us see in detail what we understand from the word derived physical quantities. Derived means taken out from. So as we have seen, area is twice of length, volume is a cube of length. Similarly, say if we take density, it will be mass by volume. For mass, what we will take? For mass, we will take kg. And for volume, we will take meter cube or centimeter cube. So we'll write meter cube, or we can write kg per meter cube. Also, we can write gram per centimeter cube. So if we take mass as kg, then we will take a bigger unit, meter. If we take smaller unit of mass, then we will take smaller unit of volume also. Okay. Now let us see how we can relate time with derived physical quantity. Say, if I want to find out speed, speed is distance by time. So distance by time can be written as length per unit time. So for length, we write meter, and for time, we write per second. Either we can write per second like this, or we can write length inverse of second. Say, if we write acceleration, it will be velocity by time. For velocity, we can write displacement by time and divide by time. So this will become length by square of time, or we can write meter per second square. So these all are derived physical quantities: speed, acceleration, density, volume, area. Sometimes there can be two physical quantities which may sound different, but they might be made up of same fundamental physical quantities. So the dimension of physical quantities is depicted by a few letters, like mass is denoted by m, length is denoted by l, and time is denoted by t. Now let us see if work and energy are same physical quantities. See, from our common understanding, we know that work done is equal to the energy lost. So as much energy will be lost, that much will be the work done. But how we can prove it? Using the physical quantities denoted by mass, length, and time. Now, there is a term given for this short form. It is called as dimension of the physical quantity. Okay. So this we call as dimension of physical quantity. So let us study a little bit about dimension of physical quantity. So if we take the physical quantity work, we all know that work is equal to force into displacement. We have studied this in our previous classes. Further, we can write force as mass into acceleration into displacement. And for mass, we can write m. For acceleration, we can write L t to the power minus 2. And for displacement, we can write length. How for acceleration we are writing L to the power minus 2? See here. For acceleration, we had found it is equal to velocity by time and it is equal to length per unit time square. So it will become m ls square t to the power minus 2. Now we'll see energy. We can take any form of energy. We can take kinetic energy also and potential energy also. So we'll take both or maybe one. Say potential energy will be equal to mass into acceleration due to gravity into height. So if we take this, for m, we will write m. For acceleration due to gravity is also acceleration, so it will be L to the power minus 2, and height will be L. It will become, this has to be kept under the square bracket. This will become m L square t minus 2. Now, if you take kinetic energy, then also you'll get the same value. Kinetic energy is equal to half mv square. Constant will have no unit. Okay. So for mass, we can write m. For velocity, we can write length per unit time and overall square of that. And it becomes m L square t minus 2. Now, if you compare equation 1, equation 2, so there was a little power failure. So if we compare equation 1, which we have seen here, equation 2, that means this one, and equation 3 related with kinetic energy, we find that the dimension of work and energy is same. It is m L t minus 2. So we can say that they are same physical quantity or similar physical quantity. So mathematically, we can prove that the amount of energy which we have, that much of work we can do, or the energy lost is converted into work done. So in our next class, we will be studying about some more physical quantities, and we will do the dimensional analysis. That means we'll find out the dimensional formula of various derived quantities or derived physical quantities. As of now, you can practice a small question. What you can do is you can find out the dimensional formula of work, kinetic energy, and potential energy and compare them. So for you, the homework would be I can give you a small homework for practice. Find the dimensional formula of A, work, B, kinetic energy, and C, potential energy. And question number 2, compare the dimension of work, kinetic energy, and potential energy. So in comparison, what you have to write? You have to write that the dimension of work, and energy is same, and hence they are similar physical quantities. They are similar physical quantities. So this type of process is called as dimensional analysis. So finding out dimensional formula and comparing one physical quantity with the other is called as dimensional analysis. So in the next class, we will see a few more physical quantities and their dimensional formula. Thank you as of now. See you again in our next class.